George, what a mess, son. What a mess.
Number is 11. There's number 11.
Oh. Tight quarters, George.
So when this Packard came in and we started getting into some of the electrical problems with it, we noticed that there were a lot of bare wires. There was a lot of burnt and melted wires. Basically, it was a fire hazard waiting to happen. So we ordered a wiring harness from Y&Z Wiring, and for the last 3 days now, Mike and I have been tearing out the old wiring, putting in the new stuff. So the main harness is in the dash, is being put back together right now. We have the taillight harness that's it's attached to the light, but we got to run it through the headliner. Little things here and there. It's a very tedious project, but all we have left is final touches on the main harness, wiring in the taillight harness, and then we need to tackle the overdrive and the heat and AC harness. So while I've been waiting for AC parts to come in, I started fabricating the wiring harness for the windows because Y&Z does not sell one. So basically what I did is I fixed the wiring that was in the engine bay for the pump, and then I pretty much ordered a shit ton of 14 gauge wire from Napa, which is the correct wire for this system. And then all this spaghetti over here is the wiring harness from the two rear doors, the wiring harness from over there. And basically what I'm going to do, because of how it was originally ran, you can't access it. So I'm going to run it a different way under the dash, and I'm actually going to use a weather pack plug so that you can disconnect and connect the system at will in case you ever need to service it. So last week I got all 3 of the blower motors in. This morning me and Mike pulled over the refrigerant bypass valve, realized that it's just a fancy phrase for the compressor. Got the compressor wired in, and then last week I started working on the control system because we finally figured out what's going on there. So I have my relay, which goes ignition to the relay, and then this is the on-off switch for the blowers, all of them, and then these are the speed control switches for the blowers. So that's 3 of my 4 switches I have sorted out and ready to go. And then basically the only switch I'm waiting for, I ordered it last week, is a resistance unit for the entire system, and it's basically going to be a hot cold switch with a resistor wired in. So that's how that's going to go. So these will get mounted probably tomorrow, and then this will hopefully be ready to test and work. So I wired in all my switches, figured out how this is going to work. I can explain that when it is working. But I did have some issues. I had wired all my ends onto my wires before I mounted my switches, and so 2 of my wires were gonna short out against the housing in another switch. So right now I just cut the ends off, soldering new ends on. But now I have my left blower switch, my right blower switch, my on-off switch for the whole system, and then I also have a rheostat, a temperature control rheostat. And then basically what's going to happen is once I get this all wired up, mounted, tightened up, I am going to figure out where these are going to mount. I'm going to mount these. These are the resistance units for a heater assembly. I got to figure out if I'm going to make a housing or something for them. But basically, these are going to get mounted somewhere under the dash where they can't short out or burn up. And then we are going to test this unit and see if it works. But my switches are in, my resistors are about to be in, my relay is about to get mounted. So now we're just dealing with the spaghetti unit. So this is a little bit of a finesse kind of soldering. Basically, you really shouldn't solder with butane torches. You can, but you shouldn't, because it'll melt the wires and cause all kinds of problems. So what I'm doing is I have it on the lowest flame it'll go. I'm not actually holding it onto the wire. I'm holding it off to the side to heat up the fitting. And once the fitting is heated up enough, I can solder the wire and this is called the Douglas connector on. So these are the two lead wires from the blower motor switch to the blower motor under the seat, which was a special factory equipment on the Packard. So this morning I went through and I tested the under seat fan. And so now I'm wiring up my switch, and the goal is to have the dash officially finished up today. I've been adding in resistors where they're needed. We did upgrade a bunch of things to 12 volt. Follow me. So this is the whole, we're gonna go through the whole car right now. So both those motors are 12 volt. I put in a new thermostat in the housing. So that is the rear section of the Frigicar system. If you come up to the front, I put a resistor into the antenna, so it is now a 6-volt antenna. I tested it yesterday. It does go up and down, so hopefully we'll have radio signal once I put a resistor to the radio. Other than that, I am putting leads in from the, this is the blower motor switch for that blower motor over there. So I put a resistor, you can't even see it, it's hidden so well. I put a resistor there. I'll have my 2 wires going there, that'll be done. I have to mount, these are 2 more resistors. These are the resistor switches for the Frigicar system. I gotta create some kind of box or some kind of mounting system for them, but they're wired up and ready to go. I just gotta test them. I gotta do a little bit more wiring with the gauges. They need some resistors in there, but we put in a 12 volt ignition. The light switch is just a switch, it don't matter. If you come over to the engine bay, so I put in a 12 volt coil. I put in a 12 volt blower motor up front. We wired up the compressor, that's good to go. This is not a generator. This is an alternator that has been manufactured to replicate a generator. So it looks like a generator, it's not. These are kind of brilliant if you are doing a 12 volt conversion. So if you're doing a 12 volt conversion, consider that. On top of that, we got the starter wired up correctly. I created and fabricated a wiring harness for the power windows. I gotta test that solenoid to make sure it works. I created a harness for the transmission because our wiring was just kind of wonky with it. Wired up all my switches correctly, got my antenna wired in correctly. Headlights are 12 volt. We did 12 volt conversion on the headlights, so those don't need resistors. I think that covers everything. We've done a lot to this car. It's been a two-week project now. It's been a lot. So part of doing wiring is seeing what people do to fix their own wiring and being like, well, that's just not okay. So I'm going to show you guys a little something. So we're doing a 6 volt to 12 volt conversion, and part of that is 6 volt components typically cannot run off of 12 volts. They'll run for a short amount of time, and then you're going to burn up the internals, and then they're just not going to work. So you can either swap out all your components for 12 volt components, or you can do a little wiring magic. So this little blue thing is a metal film fixed resistor. It is a 2 ohm resistor. Now, there is a couple of laws called Ohm's laws, and basically you can drop down voltage by adding adding resistance. So this is 2 ohms. So a 2 ohm resistor will drop down 12 volts to 6 volts. You just divide 12 by the ohms and you get your desired voltage, 6 volts. So this is actually the lead to the clock. It is a 6-volt clock. So what I've done is I've taken the resistor, I've done a Western Union joint, and I'm going to do a little bit of butane soldering just to make this quick. And we talked about butane soldering earlier. It's not recommended. You can do it. You got to be careful not to burn up your wiring, not to burn up your resistor. I really like this snap-on torch. You don't have to use a snap-on torch. You can get a butane soldering iron, but it's quick, it's easy. Basically, you're gonna put your flame under the solder. Heat rises, keep that in mind, and that's gonna heat up the wire. You're gonna be careful not to burn the wire. There we go. Saw some solder start to melt. Tilt it up a little bit. There we go. So you can see that melting right now. And basically, as the wires heat up, that's gonna sink in and create a solid chemical and mechanical connection between the resistor and the wire. You put some heat shrink over the whole thing. And basically, this resistor will never come loose, will never move, will never cause any problems for anyone. Let it sink in a little bit. Do the other side. So basically, and you can tell, well, maybe you can tell, this is a fuse holder. This is a 20 amp fuse holder. So power will run from the power source through the fuse like it is supposed to, and then drop down to 6 volts after the resistor. Hopefully. It's supposed to. Gonna knock a little bit of that solder off. Torch off. And then here's the thing, you always want to make sure that's not hot. It's hot. You always want to double check your soldering. So I am gonna give this, once it cools down, I'm gonna give this a good yank, make sure it ain't going nowhere. And you can see I am pulling on that. It's not gonna go anywhere. So what I'm gonna do is I'm gonna take some heat shrink. I think this is the wrong size. Looks like it's gonna be the wrong size. Heat shrink over it. No one will ever know it's there. And we will have a 12 volt to 6 volt conversion for a clock.